we finally made it to a conversation about adding and subtracting fractions. So the way that I want to introduce this is with some drawings, because again, they're so important for us to visualize what's really happening. So we're going to start with the problem a half plus a half. And a half plus a half would look something like this. We've got half of something plus a half of something, and we are now merging them together. We're combining them. And when we do that, what we end up with is two halves. And two halves make one whole, right? Two halves equal to one. Now I'm going to contrast that with a half plus 1/3. Okay? So let's look at that. We have a half, and we're going to add that to a third. So I'm going to split this picture up into 3 equal sections. So we have a half again, but now we have to add it to a third. In the drawing, right, and try to picture what this drawing would look like, right? We would have something like this, where we have half, and then we would have a third. Well, how much is that? Can anybody tell just by looking at it? Because I can't. I can't tell how much that is. And the reason I can't tell is because these two things, this and this, are not the same sizes, right? This section and this section are different sizes. So we don't really know what they turn into when we put them together. And it has to do with these denominators, right? When we're adding things, we want to add common things. We want to add like things. And so the way we do that is we get a common denominator. 1/2 plus 1/3. The way you've probably always been taught to think about this is look at the denominators and see what can 2 and 3 divide into evenly. What number are 2 and 3 both divisible by? And you might just sort of figure out that they're not divisible by. What number is divisible by both 2 and 3? Sorry, I phrased that incorrectly. And it's 6. 6 is the number that they're both divisible by. So what we have to do is we have to change, I don't even like saying it like that, change the denominators to 6. But we already know we just can't do that. What we're doing is this problem again. Remember this from a little while back? Raising fractions to a higher term. We want to take both of these fractions and change them so that they have a new denominator. We want 6 down here in both denominators. So we think about that as, again, what do we have to multiply by to make that happen? And we have to do the same thing on top and bottom, right? K over K. So we say 2 times what gives us 6? 2 times 3 gives us 6. So we do the same thing to the top. So we're restating the number a half as 3/6. And over here we do the same thing. 3 times 2 would give us 6. So on top, 1 times 2 gives us 2. So what we're going to do is we're going to rewrite this problem down here as 3/6 plus 2/6, right? We have 3/6 here. Oops. Do yellow. 3/6 plus 2/6. Okay? And the answer would be, well, I wrote it wrong. 2/6. Sorry, 3/6 plus 2/6 is 5/6. You're counting how many sixths, hard to say, sixths there are. And we add the numerators, right? The denominator stays the same because we're just counting how many of them there are. We add the numerators. And that's what this picture represents, right? We could break this picture into sixths, and 5 of them would be shaded. Okay, so let's have a little fun now. One of the things that's often hard about adding fractions, maybe the hardest thing, is coming up with this number. Coming up with what is that new denominator going to be. Now, 2 and 3 was probably very doable for many of you watching. But sometimes it can be a little more difficult. So I'm going to give you a new way to look at it. And it's something we've already introduced just a little bit. So we're going to take 3/4 and we are going to subtract 5/6. Okay, subtraction and addition both require you to get a common denominator. So let's see. One common denominator. Again, one way to look at it would be, what do 4 and 6 both go into? And you might just come up with that right away. I'm going to give you a slightly different way to think about it. And it has to do with prime factorizations again. Don't we love those prime factorizations? So I'm going to look at the number 4 as 2 times 2. I'm just going to jot that right beneath it. And over here on the number 6, I'm going to do the same thing. 2 times 3. And what we're going to examine is now, what do they have in common and what do they not have in common? Let's see. This one has a 2 and so does this one, right? So in order to get these two denominators to be the exact same number, they must have the exact same factors. So watch this. 4 has an extra 2, right? So we can multiply this fraction by 2, which would give us times 2 on the top, times 2 on the bottom. This fraction has an extra 3. So we could multiply this one by 3, which would mean a 3 on the top and a 3 on the bottom. So what you're looking at in these prime factorizations is, what does one denominator have as a factor that the other one doesn't have? And then you sort of share it. You're sharing those factors that the other thing might not have. Well, look at what we have here. Again, this fraction gets multiplied by 2 and 2 on top, and this one by 3 and 3. Let's see what that looks like. 3 times 3 is 9. 4 times 3 is 12, minus 2 times 5 is 10, and 2 times 6 is 12. So the common denominator, I never put the R, common denominator is 12. 4 and 6 both go into 12. We built the common denominator. In fact, this is the same thing we did back when we were looking at least common multiples at the end of that previous unit. We built it based on the prime factorizations. Now we just subtract across the top. 9 minus 10 is negative 1, 12. There we go. Let's try one more. This one I definitely want you to pause the video, try this yourself. 11/18 minus 7/24. And see if you can build a common denominator using those prime factorizations. So I think about the number 18. If I do a factor tree, I would end up with 2 times 3. I'm going to make it a little smaller. 2 times 3 times 3. 2 times 9 is 18. 24 is 2 times 2 times 2 times 3. 4 times 6. So now we compare the two prime factorizations. Let's see. This one has a 2. Let me actually highlight them instead. I'll highlight what they have in common. This one has a 2. So does this one. You don't need to duplicate things that they already have in common. This one has a 3. And so does this one. Okay. So now look at what's not highlighted. This is what you need to share. So, let's see. This has a 3. So this one needs a 3. So we would multiply the top and the bottom by 3. In a different color, this one has a 2 and a 2. So this one needs a 2 and a 2. So I'm going to multiply these by 2 times 2. Now I can write 2 times 2 or I can write 4. It doesn't matter. Either way is going to do the same thing. So now let's do that multiplication. Let's bring it down here. 11 times 4 is 44. Over 18 times 4 is 72. Minus 7 times 3 is 21. 24 times 3 is 72. Look at that. We magically came up with that. It's not magic. Mathematically came up with that common denominator without even trying to figure it out. We built it using those prime factorizations. 44 minus 21 is 23 over 72. And this is a prime number on top, so there's nothing I can even do here to simplify or reduce it. So just to sort of reiterate that, factor the denominators, see what they have in common, share what they don't have in common, multiply the top and the bottom by that number, right? So we're multiplying by a common factor on top and bottom. You build that common denominator, and then you can add or subtract. And that is adding and subtracting with fractions.